learn more, go practice, and just make sure you're able to design a network that is scalable. We've used the default subnet mask. In the previous session, we were able to design two LANs, two local area networks. Network 192.168.1.0 and network 192.168.2.0. And if you can recall from our design, we had these two configurations. One, in the first configuration, network 1, in the first network 192.168.1.0, we saw we have 256 IP addresses from address 0 all the way to address 255, which means we have 256 IP addresses. However, we are not using two IP addresses. The first IP address .0 and the last IP address 1.255. So these two IP addresses are not assigned to hosts or end devices. So the only available IP addresses are from 1, 2, 3 all the way to 254. So these are 254 IP addresses, 254 valid IP addresses. Okay, the same thing with network 2. We can only assign our hosts at IP address 1 all the way to 254. The first one not used because it's used for identifying the network, and the last one being used to broadcast to all devices in that network. And for simplicity, we are using the default subnet mask 255.255.255.0 because you're saying the first 3 octets are used to identify our network. And since the first 3 octets are different, this is 192.168.1 and this other one is 192.168.2, these are two different networks. So in our previous session, we designed a logical topology for LAN 1 and then another one for LAN 2. The first topology is for LAN 1, which has the IP address 192.168.1.0 to identify the network. And in that network, we have these two devices, 1.1 and 1.2. You're noticing as well that the first 3 octets are the same. That means these two devices are in the same network. And if they're in the same network, it means you can just forward messages from PC1 to PC2 and back through the switch. We can test that. To check the IP configurations, we just type IP config and it will show us this is the IP address and the default subnet mask. We can ping the other device to test connectivity. Ping device 2 192.168.1.2 and you can see we're able to reach the other device. 0 packets lost. So within a LAN, devices can communicate. However, PC1 cannot communicate with PC3 because we need a connection linking these two networks. And for us to achieve that, we will not use a switch. A switch is a layer 2 device within the OSI layers. So when you're looking at OSI layers, we have layer 3 will need a router, and you also have layer 2 which will need a switch, except cases where we have multi-layer switches. Multi-layer switches can operate on both layer 2 and layer 3. When enabled, it can do layer 3 functionality. Okay, so let's add a router. So we'll go to our tools, select router. We have different types of routers: access router 201, access router 1220. You can just pick the generic router here, R2. As usual, we also need to power this router. So it will just boot up like any other computing device. It will load the operating system. In this environment, the operating system is called VRP, Versatile Routing Platform. You can just click on display version and it will show us that it is Huawei Versatile Routing Platform Software, VRP. And this is the version. It may not be the current version, but as you can see, you're able to see the version of the operating system running within the devices. Now, the router has been added. So we need now to link the router to the switches. We'll go to our connections, still use LAN cable, the copper cable, connect it from the switch. We'll prefer to use Giga Ethernet connections because of slightly higher speed, so that in case you have multiple devices within the LAN, you can have higher speeds forwarding the messages to the layer 3 device. So you can use the port 001 and then as well come here and connect it to 001. So we have this interface 001 001. You can use any other interface, it will still work, but for this design we can consider 001 001. We also do the same for this other side. We can use G002 because it's LAN 2, and then when you come to this as well we use G002. Okay, just like in the other one, you can still use any other interface. We are sharing a router. We are linking those two networks using a common router. So that means LAN 1 and LAN 2 have directly connected LANs. You can go to the router, display. You can display the routing table, display IP routing table. At the moment you can see the loopback connections. No other connections configured. So the next thing we need to think about is how do we configure the interfaces G001 and G002. What you can see from the routing table is the destination and the mask, subnet mask, the protocol, pre-value, cost, and flags that determine how packets are forwarded from one router to another. To achieve transmission of packets, the first thing is, since we have LAN 1, we need to have a private IP address assigned to this router that is facing this network. So it means it should have the same IP address range as LAN 1. In our case, we can assign it 192.168.1.3. It should be among the valid IP addresses. So for this interface, we can assign it this IP address. For this other LAN, LAN 2, we can also do the same. For this interface, we'll assign IP address 192.168.2.3. Okay. Routers carry two IP addresses. How it is seen from the inside of the private network and how it is seen from outside. Okay, let's say you have an ISP or other networks. How is it seen from the other networks, or how is it seen from the inside? So when you're looking at the inside of the LAN, then they should have an IP address in that same range. From this other side, it should also have an IP address in the same range among the valid IP addresses. So that's our design. So to configure specific ports, we have now to access the specific port. We go to the system view of our router and then go to the specific interface, and our first interface is G0001. So you'll type the command int G0/0/1 and you've accessed the interface, and you can run commands. If you just type a question mark here, it will show you all the possible commands you can run on that interface. You can see in our case, for us, we just want to assign an IP address. So which command do we use? So the command we'll be using is IP. Specify IP configurations for the interfaces. Okay, so we'll go down and just assign IP address, IP address 192.168.1.3 space 24. You may ask yourself, why are we adding 24? 24 is the mask, is the subnet mask. Remember, we're using class C IP address, and the subnet mask, the default subnet mask is 255.255.255.0. And when you convert the number 255 to a binary number, it is a group of 8 bits, 8 ones. So that's an octet. We'll have first 8 bits, another 8 bits, and another 8 bits here. So those are 24. So when you have 3 octets, you'll have 24. That's the reason why we're using it here. So instead of writing 255.255.255.0, we just specify the IP address space 24. And then when you press enter, that specific interface is up, and it has been assigned the IP address 192.168.1.3. Control Z, we go back, and then now try and recall the display command. We like to display IP routing table, and when you display the IP routing table using the display IP routing table command, you can now see the new entry here in the routing table. It's a direct connection. This is the IP address 192.168.1.3. System view, go now to the other interface. So we've configured G0/0/1. Now we need to configure this other side, G0/0/2. So int, we access the interface first, G0/0/2. So we'd like to access that specific port, that interface, Giga Ethernet port, and we've done it. The next thing now is for us to assign the IP address. IP address 192.168.2.3. 168.2.3 space 24. Enter. We are done. We've configured the two interfaces of the router, and now when you check the routing table, the two are being considered here. The destination, okay, 2.3, 1.3. Protocol, they're direct connections. If you had configured protocols like OSPF, open shortest path first, it will learn it dynamically. So there are protocols you can still configure the system to use. If it's learning routers that are beyond the directly connected router. Example is OSPF. OSPF stands for Open Shortest Path First. So it will learn dynamically. So when you're looking at the routing table and you look at that instance when you have activated OSPF, when you look at the protocol, instead of showing direct connection, it will be able to show you it has been learned dynamically and also some parameters here in terms of pre-value and the cost. Though sometimes you can still override this if you're prioritizing certain specific links. Okay, so by doing that, our routing table is now updated. So the next thing now we need to do is when you come to our devices, at the beginning we didn't assign a gateway. So even if the router has been configured, yes, you can ping. You can try to ping the device in the other network. So we can ping 192.168.2.1 and still the host will be unreachable even though your router has been connected and configured. So the only pending task is to make sure that even on our PC we need to assign the gateway. The gateway now is your local router. If a packet is received or it is sent and the destination host is not within that LAN, then that packet should be forwarded to the gateway, and the gateway is your local router. Okay, so we need to assign the same IP address that we did to that interface here, 192.168.1.3. So in case the destination of the packet is not found within the LAN, then the next hop will be the local router. You forward it to the router, and then router will check the routing table and look at the best route to forward this message. If it's directly connected, then it's easier. You just forward it to the other port, and then the port will forward this message to the switch, and from the switch to the specific device. So we've done it for this device. If you go to PC3, we do the same thing, 192.168.2.3, because we have to assign the IP address of the local gateway from this other side. Okay, so that's why we have 192.168.2.3 and then applied. You can even close this and then come back to PC1 command. So if we run the same command, initially remember we were trying to reach the PC here in network 2. We were trying to reach PC3 and we were having host unreachable. Now, since we've specified the gateway and the router is configured, when we rerun the same command, what happens? Zero packet losses. And that's how communication is successful. We can also do the same. We can just come here. You can capture packets. We can even capture it from here. And try. Let's try from our PC3. When you go to PC3, can I ping PC1? You can see it here. Look at IP config of PC3 and you can see it is in network 2.1 and the gateway we've assigned is 2.3. Now we can we ping PC2 192.168, sorry, 168.1.1. Yes, it will be able to ping. So it will do the same, and you'll notice from our router here, it's able to forward the packets. It's able to forward the packets, request, reply, and finally, no packets were lost. And that's how now we've been able to configure, create this logical topology to make sure that these are devices in LAN 1, they can communicate between themselves, and then devices in LAN 2 can also communicate between themselves through the switch, because switches have MAC address table. Display MAC address, and you can see the MAC addresses and the ports. And it was lamped dynamically. And the routers have routing table. Okay, that's why in your institution, in your organization, the device that's the heart, the central of that organization to allow you access the internet is the router. In your home, it's the router. We need switches to allow us connect to more devices. But for you to connect to the public network, to the ISP, internet service provider, you need a router, because a router carries two IP addresses, how it is seen from the inside the organization and how it is seen from outside the organization. So locally here, you will require a private IP address, address that you don't have to pay for, a private IP address for the duration of use. And then outside, the one that's issued by the service provider is a public IP address. It's a public IP address. And both can be in class C range. The range of class B IP address that is supported and you don't have to pay is from 192.168.0.0 to 192.168.255.255. So it's this range 192.168. However, anything outside this range can be issued as a public IP address. It can be 193, 194, 195, 196. Okay. So go find out what's the range of public IP addresses in class C. And how can I achieve the same thing if I'm using class A or even class B? IP version 4 IP addresses. Learn more, go practice, and just make sure you're able to design a network that is scalable. We've used the default subnet mask. How do you achieve subnetting? Thank you. We meet in the next session.